All right, we can get started. Again, briefly, my name is Diana Sinton, and I'm here on behalf of I-GUIDE. We're very happy to add this as the next in our series of virtual consulting office sessions, which are our weekly sessions that focus on some technical topics related to the work with geospatial data that we do, often involving spatial AI or geo AI. Today, we are very pleased to be able uh, to have Julian Huang from University of Chicago and Yui Lin from UIUC join us. The two of them were involved in I-GUIDE's 2024-2025 Spatial AI Challenge, and they're going to be sharing about the work that they had done with that. Just as a reminder for people, we are currently still accepting abstracts for our 2025-26 Spatial AI Challenge. The deadline to submit an abstract for that is Saturday, November 15th. And I will put the link to that into the chat later. But thanks for joining us today. Just one more quick reminder, this is a regular Zoom meeting, so you're in charge of your own microphones. Please keep them muted throughout the presentation, and there'll be a chance to ask a question at the end. So with that, I turn it over to Julian and Yui.
Hello, everyone. I'm Julian, an undergraduate at the University of Chicago. I worked on this project with Ira, who is an assistant professor at UIUC. Yeah, do you want to introduce yourself?
Yeah, so last December we saw this call for abstracts from I-GUIDE and was for a spatial AI challenge. And Julian came up with the idea of using open data for roof material detection, and then we put up an abstract and submit to this challenge. So yeah, so I'm Julian. So last year I was working at the University of Chicago as an instructional professor, and that's how I met Julian, and we work on these projects. And now I moved to the University of Illinois Urbana-Champaign as an assistant professor. So yeah, so Julian would talk about our projects in this presentation. Yeah.
Yeah. I guess we can start with the motivation behind our project, which is about predicting roof material and roof shape labels from satellite imagery. So first of all, why do we care about roof materials and roof shapes? Specifically detecting, taking an image of satellite imagery and detecting like being able to map out which roofs are made out of tile, for example, as opposed to cement or concrete, and for shape, seeing which roofs are gabled, for example, or flat. So there are multiple reasons. One of them is about about solar energy. Knowing roof geometries is very important for solar energy forecasting, and like testing the applicability of a certain area for or certain houses for like solar panel retrofitting on the roofs. Um, Especially in developing countries, roof material and roof shape are a really important proxy for socioeconomic development and disaster resilience, where some roof types, such as cement, although they're more expensive, are way more resilient to disasters, such as flooding or hurricanes, as opposed to something such as corrugated metal or tin. And this will give us a good proxy for which areas are more are less resilient to disasters and should deserve more government investment, for example. And why open data? Since the goal of this project is to uh, create a reproducible pipeline that can then be applied for more disaster-prone areas or lower-income countries, we want to demonstrate that this can be done with open data that currently exists out in the wild. There are some limitations to the open data, which we will talk about later, but using open data and doing a fully reproducible pipeline was a key component of the I-GUIDE Spatial AI challenge, partly because of scientific reproducibility um, and uh, a- and good like scientific practice. But in this case, it's also very like directly related to the sort of applications we would like this project to have. So what are some challenges? Why is this not like immediately doable? First of all, OpenStreetMap data is not automatically, sorry, for context, OpenStreetMap is sort of like I'm sure most of you already know what it is. But it's sort of a Wikipedia for maps where people are able to add their own sorry, are able to label different elements such as roads, buildings, and crowdsourcing these labels to make something such as like Google Maps. But um, a lot of buildings happen to have roof material labels, which means that people took the building outline and manually entered a tag for which material the roof was made out of or what shape the roof was made out of. The problem is not that only exists in very select few portions of the world. People didn't do that everywhere. Um, and there's a lack of there's only a few existing papers or benchmarks that have tackled this challenge before, but they either use very expensive data, such as like drone collected data, or and then they require like they had a lot of manual labeling of the data, which is very expensive and time consuming. Uh, the second main challenge is that roof material and shape detection is somewhat hard from satellite imagery, as a lot of the roofs will be similar in color and visual features. And a lot of and especially with lower resolution satellite imagery, it's going to be hard for models to detect the difference between different roofs. Hopefully, this gives a better sense of why we decided to take on this project. Um, So the first step was to do data collection. Um, so there, I'm gonna, so these are some tools that we found very useful throughout the process of both like finding the study area of where to collect the data and um, where data is available on OpenStreetMap, and second, querying OpenStreetMap uh, to actually like get these labels at a very large scale. So Tag Info is a website that um, shows you you can select a specific tag that you're looking for. In this case, these are bench tags, and um, it'll show you a map of where this is distributed around the world or in specific countries, within specific countries, and it'll tell you the quantity of labels. So there are just some areas in the world where people have decided to map certain things more than others. And it's not the case that if you just select a random area of the world, um, like it's going to have good high quality data. So a lot of this process is about selecting the right area, um, seeing what data already exists if you don't have like manually collected data. Um, so we narrowed down the area to Germany, which although this isn't a very like in terms of our main motivation of uh helping disaster prone areas or still like lower income countries, not very important, but um had very high quality data that could serve as a proof of concept that this pipeline would work, which could then be applied by actors with maybe like manual labeling or their own data sets to apply this pipeline later on. And um, another reason why we chose Germany was that there's enough diversity in roof labels in the first place. And in order for this to be an interesting task to train the model to detect different labels. Um, and then we query using the Overpass API, which allows you to select the bounding box, select the label that you want or the tag that you want, and get a GeoJSON for all of the elements within the area or all of the outlines within that area that have that uh, tag. So we use this to query for both roof material and roof shape and near Cologne and Bonn in northwest Germany. Um, yeah, so so data pre-processing was the main aspect of our work. So the OpenStreetMap data is not immediately usable. Even in an area with Germany, which like in the specific area of Germany, which had the highest quantity of roof material labels. The OpenStreetMap data wasn't perfect because within this area, there were a lot of different like smaller patches without as many roof labels. And because of this, if we kept those patches, that would create a lot of false negatives for the model, and that would potentially decrease the model's performance or ability to learn from this training data. So we had to filter out patches with less than 3 labeled buildings or less than 70% roof lab. Um, yeah, so less than 70% roof labels means that there exists building outlines there, but there doesn't exist like a label for what material that building had. Um, Another thing we had to do was manually align the building outlines from OpenStreetMap to the specific satellite imagery we're using, which is actually from OpenAerialMap. Uh, the Another reason why we chose this area of Germany was that there already exists like high resolution satellite imagery from Maxar's open data program, but this doesn't exist everywhere in the world. So we envision that if people have their own sources of satellite imagery, they could carry out this project in other areas of the world. But since we were trying to use mainly open data, this is another reason why we selected um, Western Germany. The next thing we did was extracting patches of sizes of 384 by 384 pixels with a 96 pixel overlap. The um, task for our model was instance segmentation, which is different from classification in that the models are outputting a bounding box for the roof label as opposed to like a binary outcome, sorry, not like a categorical outcome. So which is why the data we inputted was like patches of satellite imagery with uh like these patches having at least 70% of buildings within the patch have a building material label. So you can see an example of our, sorry, this isn't an example of our data sets. In the next, you can, this is a example one of a subset of a patch. The actual patches were a bit bigger than this, um, but you can see that the data, um, the input data had both the bounding box um, and the actual instance segmentation mask, uh, and also a label for that mask that was fed into that that was fed into the model. Um, so we introduced two new data sets. One of them is roof shapes, which is sort of the geometry of the roof, which is this thing. Um, so whether the roof is gabled, which is it has like two sides leading up to a top, or flat, and hipped was a rarer class. Most of the both of our data sets had a lot of class imbalance where the vast majority of the classes, say 80%, were part of the two most common classes. For roof material, that was gabled and flat. And for roof shape, it was gabled and flat. And for roof material, it was um, tar tiles and concrete or metal. I forgot which one it was. So we fine-tune Ultralytics YOLO 11, um, which is an open model on this on our data sets. Um, sorry, I think I might have skipped over some. Oh yeah, sorry. Um, the main part of data pre-processing is turning this like OpenStreetMap data, which is saved in coordinate format, into YOLO's instance segmentation format, which requires that you normalize the coordinates to the bounding box. Although and uh, like save each image as with along with metadata which says where within that image the building outlines are and what label each of these building outlines has. Um, our model achieved a precision of 67 for the bounding box detection task, which is the model outputted not just like predictions for where the which roof material things were, but also what um, bounding box, sorry, where within the image there were roofs in the first place. So for the bounding box task, the model achieved a precision of 67%. And for the actual like masking task, I think this was measured through intersection over union, which is the amount of like shared pixels over uh, the amount of like total predicted pixels and ground truth pixels combined metric. That achieved a 66.38% precision. So although this is definitely not production ready, we envision that there are a lot of like data. We'll go into the next steps in the next slide. But this is pretty promising performance for the first instance of the model. And with certain improvements to the data set and model, I'm sure that we could achieve much higher performance. And for the most common class, which was gabled roofs, the model achieved a like predicted accuracy of 0.81%, meaning that 0.8% of gabled, sorry, 81% of, sorry, not 0.8, 81% of gabled roofs were accurately labeled by the model. So what were the challenges in this case? One was data quality, where occasionally you would get, since this is OpenStreetMap data, you would get data from a long while ago that corresponds to older satellite imagery, but also there's a lot of irregularities in how people label the data. For example, some people labeled garages and split houses into their multiple subsections, which is not ideal, as opposed to actually labeling as opposed to labeling like entire buildings as one. And even within the patches, 70% like just having a threshold of 70% of the buildings have an actual ground truth label means that there are potentially up to 30% false negatives. And that could lead the model to output a lot of false negatives or not fully learn from the data set correctly. Um, Another challenge is class imbalance. So as you can see, the model performed pretty badly on the rare classes simply because they didn't show up that much in the training data. And um, that um, that could be solved by better filtering for like classes with a lot of uh, roof materials, or that I think this would also be solved with just a much larger data set, um, such that these rarer classes would be more represented. And another challenge is that um, because the areas of the world with open high quality or high resolution satellite imagery was very limited to the areas on OpenAerialMap or the Maxer data collection program. This is why we had to select such a narrow data. Whereas we initially wanted to do this in an area such as Nepal and or Sri Lanka or India, which happen to have some roof material labels, but not many, and would be much like this would be a much more impactful study um, if we did this in an area that like was more prone to natural disasters and would require this type of study. So, but we couldn't find any open high resolution satellite imagery in those areas, which is why we settled on Germany. And another challenge is the visual similarity between classes, making this somewhat hard for the model to learn. So we think that there's a lot of future potential for this method though. So if we had more time, a lot of things that we would do are probably related to improving the data sets. So both just getting a lot more samples and ground truth labels and from all across the world. Actually, I think that it's better if you um, train a model that is specific to a country rather than unless you create a foundation model that is like good at performing all across the world. Um, and this is because of a lot, I think the model picks up on a lot of like quirks in the satellite imagery that are specific to a country, and that because of the imbalance in which countries have roof material label versus which countries don't, there are going to be a lot of like issues with what labels the model is better at predicting, and there are a lot of countries that just like have zero roof material data at all, and this would be they would be like the model would perform pretty badly on them simply because the types of roof materials and the visual qualities of the satellite imagery would differ in between countries. And so I think that the ideal case would be a lot more data from within one country, and perhaps that could be done through more manual collection or like better sourcing of already existing data that we just didn't happen to find. Um, Another we think that like if we had more time it might be beneficial to manually like sort through the data and fix labels and clean out bad labels as there were some irregularities and issues with the existing OpenStreetMap data, but I would say that for this subject area that we collected, Germany, the data was mostly very high quality. um, the next another thing we would do is already mentioned, just apply this to areas where this would make more of an impact. Although for Germany, one could argue that this is helpful in um, for solar panel forecasting and solar panel suitability measuring. Like this sort of information on, say, like what percent of roofs are like thatched or like tin or corrugated metal as opposed to concrete would be more helpful if we studied this in other areas. And um, another thing is that high resolution satellite imagery can be pretty computationally expensive. So one other, so we might we might train a model to do this sort of roof classification task on lower resolution satellite imagery, as opposed to high resolution satellite imagery. And one idea I had was that there are a lot of existing foundation models now, such as Omo Earth, which recently came out, which use 10-meter resolution data, but are simply like trained on such a high magnitude of data that they would have like much better priors on before we fine tune them, such that this might be viable. So like even if the model is like looking from a very like uh low resolution at an area, it still might be pretty good at detecting roof materials, which normally is a low which normally requires high resolution simply due to like the minor details in between the different roofs that like just by looking at the larger scale visual features. And this is a hypothesis that we haven't tested. And the last next step that is probably most important is that once we get a model that we are like confident enough in, we should use this for large scale prediction and inference to be able to create more roof material label around the world, especially in areas that need. Um, yeah. This is the end of the presentation. So um, I think we should open up the floor to questions, if anything was confusing or perhaps I rushed over a lot and or went too in depth into some like uninteresting technical details. But yeah.
I don't think any of those details are uninteresting ones. They're all important to produce a good final project like you all did. What questions are there any questions from the audience at this point? Feel free to can raise your hand, your virtual hand. You could type something into the chat if that's easier for you. While we're thinking about that, Julian, so I've got a couple of questions I'd love to hear about, but anyone else feel free to type something up in the chat too. So Julian, tell me what you're an undergrad there.
Yeah.
What course were you taking or courses were you taking that allowed you to learn some of these techniques and become interested in this topic?
Um, I would say that I haven't the GIS department offers a lot of great courses, but I haven't like taken any of them yet. This is mostly just like learning on my own and reading on the internet. But I think I was interested in like satellite imagery and geography for a while in high school, and read a lot and like thought a lot about geography in in the years prior.
That's really interesting. Were you familiar with OpenStreetMap data, the platform and the way it's all the data are produced, even
Uh,
in high school years?
Yeah, yeah. It is actually very funny. The reason why I was very like familiar with OpenStreetMap is because I was part of this Minecraft project to recreate the Earth, and a lot of the data we used was from OpenStreetMap.
That's excellent. How did people go about that? Like
Um,
downloading different sections with different tags and
it was mainly the building outlines. That was the only data that was good enough to use, but just getting the building outlines from OpenStreetMap and porting them into Minecraft.
hmm Excellent. Are there computer science classes you've taken in school now, more recently, that have been helpful to your knowledge? Or are
Yeah,
you still continuing to learn on your own?
Um, definitely like the main introductory computer science classes, which like tell you how to like program well in Python, I think were pretty helpful for this.
Excellent.
Yeah. And then
Uh,
sorry, yeah.
no, 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 go ahead.
And then I'm taking a machine learning class. Yeah.
Okay. What are you majoring in actually?
I'm studying math
Yeah.
and computer science.
Yeah.
Yeah.
Excellent. Yeah. Um, your types of skill set are, of course, geography is such a broad and diverse field, and students like yourself are uh, always really great to work with. We have a question in the chat wondering if you looked at census data to improve anything about uh, roof materials.
Um, do you mean as in like using census data as like additional features in the model,
Um,
or just using census data to get more data in the first place?
I'm not sure. Carolina, if you want to add some more to that, it's interesting. You can to think about the type of data that are available
Yeah.
at the census that would give some insights into roof materials. Um, there are things about housing, but I don't know at what granularity, what geography some of those um, housing attributes are actually available or provided. Uh, hmm. Oh,
Oh,
Carolina's
really?
adding that you've got information about roof material at the block level in most of developing countries.
Um, I mean,
Well,
I
that's
guess if
something else
that's
that, yeah, could be
I mean,
used to inform some of this.
I also think that like if this is the case, then like there's not really like that big of a point in the project because the data already exists. But I wasn't that aware of this. I Most of the census data I couldn't find like roof material data, but this would have probably been pretty helpful and probably solves the task that we were going for. Although the census data probably isn't like coordinate based, it is like block level based, although that's very helpful. But maybe for the purpose if you want like a rapid disaster response, then our model is still useful. But I guess if the census data exists in most countries, then that would be very helpful in should be the data we should be looking at instead of this, I guess.
Well, I don't know. I don't want to take the time to dig into the census specifics right now, but I haven't seen at a lot of developing countries the ready availability of uh, roof material, reliable roof material information at the block level. It wouldn't be at the block level in other countries. So yeah, that's something definitely to look into. I'm definitely curious about that more. Um, we have a question from Cheng Bin. Do you have your hand up? Would you like to ask your question live, or would you like to ask to type out your question?
Yeah, I like to ask thank you so much,
Great.
Julian. Very interesting work, especially for undergrad student. I like it a lot. I have a comment and also maybe a question. So in terms of you're saying the challenge about, I remember you mentioned lack of high resolution satellite imagery, right?
Yeah.
Uh, you may want to consider use some of the data from Google Earth where you may be able to save some images from there. Although I believe that there's some like restriction or clause you may want to consider, but at least there's a way for you to have to explore additional
Yeah.
data or images from there. Or you're more than welcome to contact me if you in case in the future you need additional data. Another thing I remember, we also try to do the alignment between buildings and satellite images, right? You do it by hand or automatically do that?
Oh, okay, yeah. This is actually, sorry, this makes it sound as if it was harder than it was. All of the buildings are offset by the same amount. So you can just like do it by hand and move it once and um it should be fine. Yeah, I did this by hand, but all it requires is moving all of the building labels at once because um I guess like someone did them using another piece of satellite imagery, which is slightly offset, but everything is offset by the same amount. So you only have to move everything once.
Yeah, the reason I'm talking about this because in case in some rare case some images they're not uh, correctly geometrically correct,
Yeah,
which means there may be some like tilt images instead of the orthogonal one. And so maybe this is something that you may need to consider in the near future. Just a
yeah,
comment about this, because if you're doing the handheld alignment, I guess maybe there will be a lot of work here. This is maybe something that you may want to consider improving in the near future. Well, but overall, I like the work. I think this is pretty cool. So just
yeah.
FYI. Yeah.
Okay, thank you so much for the comments.
Yeah.
I think for the yeah, I guess the tilt matters a lot because in this case you could see the satellite imagery slightly tilted, so taller buildings will be offset by a different amount than shorter buildings. Um but so there might be some issues. But for the Google Earth data, we did consider Google Earth, but in order to publicly share the data set, I'm not sure if it's within like Google Earth terms of service to like be able
Probably
to
not, but
yeah.
you may want to use like one or two images from them, not the whole thing.
Yeah, yeah, that makes sense. But for training, it might be helpful.
Yeah, yeah,
Yeah.
yeah. Well, I have one follow-up question because it appears to me that your accuracy is only like 66% ish, if my
Yeah.
memory. Do you do you have any idea how you can further improve them
Yeah. I think
from
most of the
66
issue,
to like 80 something? Probably that is what we prefer.
yeah. It's not, yeah, this is very low and like definitely not production ready. Um, so I think probably better data quality is the main thing that would need to be improved, where there are like some false negatives and um just like not enough data to learn from, I guess. And yeah, that would probably be the main improvement. Maybe we could do data augmentation. We tried data augmentation, so like duplicating and like reset or like, duplicating images with visual transformations applied, such as like rotations, flips, like lower resolution. Um, but that didn't help much or at all. So probably like the ground truth of the like existing sorry data is like the most important factor.
Yeah, actually, I want to point out one thing that is also another potential error source that is
Yeah.
probably I don't know. I just assume maybe there's a time gap between the OSM and the satellite data. If
Yeah.
something like the new building occurs or demolished, then probably it's not there, and probably that is also another potential error source.
Yeah,
That is what
definitely.
I'm thinking as well. Yeah.
Yeah.
But I like it. Overall, it is pretty interesting. Very cool. Thank you for your hard work and interesting.
Thank you for.
Sure, thanks.
Yeah.
Okay, any other questions for Julian? Julian, thank you again for sharing this. Thank you for contributing to our Spatial AI Challenge last year. There's a recording. No, well, the recording for this event will be up on I-GUIDE's VCO webpage. I was looking here to see. I'll put another link here. Julian and Yue actually came in this project last year. Earned it's the competitive challenge and earned a third place achievement in last year's challenge. And I think, Julian, there are notebooks that they might not have been updated since last year, but there is a Jupyter notebook associated with this that is on the I-GUIDE platform. That's another thing that I-GUIDE does, is put the materials, make sure that the materials, again, to promote the open science that I-GUIDE is very much committed to. The materials to support these activities are available through the I-GUIDE platform, platform-i-guide.io, and Julian's helpfully put the link to it right there. And again, the recording to this VCO will be on our VCO page. I will just quickly put that into the chat. We have pretty much, not every week do we have a session, but many weeks we have a session. We've got one next week that's going to be presented by students who were part of our summer school in the summer 2025, talking about the GeoAI work they had done, also with images. So if there are no more questions, we can wrap this up. I want to thank Julian and Yue again for their work. Please keep in touch with I-GUIDE. If anyone wants to make sure you don't miss out on a lot of our activities, I'm going to put a final link in the chat, which is our contact us page. And we have different email lists that you're able to sign up for if you choose. And then you would get announcements for different activities, including next year's summer school, the VCOs, and currently, again, we have our current Spatial AI Challenge going on. It's pretty easy just to put in an abstract right now. The deadline is Saturday, the 15th. And we're eager to support a whole nother cohort of people to be able to leverage the I-GUIDE platform and high performance computing that I-GUIDE will help provide to enable your projects. So thanks again, everyone, and take care and enjoy the rest of your Wednesday.